Hello, everybody. Are you here?
I don't even see anyone.
Amanda, thank you for responding. There are 8 of us here now. Good, good, good. All right. So what is our plan today? Okay, you have to understand for this esterification experiment, there is a report due tomorrow.
Voice off. Oh no.
The report is due tomorrow, okay, 5 o'clock. And I have already set up a Dropbox. Okay. And today I will take questions about anything about the esterification. I will also go over some of the common mistakes from grading your NMR report. Okay. I would like to address the important concept and make sure you are able to handle your final exam, because I told you before, the questions on NMR will be like 6 or 7 of them out of 30 questions in total.
Okay.
So for this reason, I have to go over, okay, some of these and be prepared to answer my question along the way. I will reward you with some bonus point, depending on whether you are paying attention or not, okay? Now this is section 04. Hold on, let me get my packet. I do hear some background noise. Okay, it doesn't bother me, but if you're able to turn off the noise, maybe some other student will find it much better. Okay, I'm fine. I'm really happy with what I see now. I think there are how many students in total? 14. And ideally, I think I have 17 students in total. One dropped just recently. All right, I think I need to get going. So is everybody happy? Did you have a good spring break? Tell me, are you able to catch up some work or relax? Some people responded to me, I slept through the whole spring break, not doing much, can't go out, cannot have fun. All right, hold on. So let me see. Okay, I want to see your response in typing. Okay, so ... Okay. Yay, yes. Oh, thank you. I'm tired. You did study? Oh, not a break. But you get rewarded, okay? Nice. Yeah, you were able to catch up a little bit. I think, yeah, it's a very important break to me also, okay? All right. Today, I want to go over some of the NMR one more time, because when I graded your report, there's some common mistakes. You nap all week. Got it. Okay, caught up, huh? Very good. Okay. All right, now let me show you. This is a slide coming from someone else, okay? And I found it quite useful. And so this is on the aromatic ring. Second visit NMR. Okay, and I want to give you one more touch-up clarification on the chemical shift or the splitting pattern, okay? When you interpret the aromatic ring, it really depends on the plane of symmetry. You will see signals depending on, you know, if you have, like for this hydrogen A right here, on this mono substituted ring, okay, mono substituted ring. You have this hydrogen A, B, C, D, E, only have 5 hydrogens on the ring. And I want all of you pay attention now and tell me how many different kind of hydrogens are here. Whoever answer first, and I'll ask you a question. All right, Cindy, very good. No, who says no? Who gave me the first answer? Okay, Emma. Thank you, Emma. Do you want to answer the question? Can you tell me, okay, what splitting pattern do you expect to see, and what's, okay, for hydrogen A, you know, because of plane of symmetry, this hydrogen E will be totally equal to A because they are only 1 carbon away from each other. Am I right? Right? This carbon away from each other in the same environment, okay? They're in the same chemically equivalence, in other words. Okay, Emma, can you tell me, what do you expect for A to present in the splitting pattern? Do you see singlet, doublet, triplet, etc.? Because I want to give Emma the first opportunity to collect a bonus point. So let me, so Emma responded, this is a singlet. I can tell you this is incorrect, okay? Lazo, did you say there are 5 different kinds? No, I can tell you because A and E are identical. Hydrogen B and hydrogen D, identical. Because when you flipped this molecule 180 degrees, face down, you'll find these 2 identical. Okay, and so, okay, so someone says it should be a doublet. Now, who said it should be a doublet? Who said that first? I want to give you the point, okay? Hold on, let me grab a piece of paper. All right, ladies and gentlemen, I keep saying this again and again. In the final exam, whatever I said today, it could be in the final, okay? So someone said this should be a doublet. Who said that? Doublet for A and E. 2.3 ppm. Triplet for 2 neighboring hydrogen. Hello. Okay, now Cindy, Aaron, Emma, I told you this is not a singlet, okay? Aaron, it is not triplet. A, I will ask you how many neighbors are there because the n+1 rule still applies. Okay, so Cindy, you're right. This hydrogen, I would not say this is aromatic. Cindy, the mistake is when you say aromatic hydrogen, you're talking about this hydrogen directly attached to the ring. Okay, and 2.3 ppm belongs to benzylic. That will be one more carbon here, and then that hydrogen attached to this additional carbon will be located at 2.3. But aromatic hydrogen here in general, the term is right, but the ppm is wrong, okay? So can someone tell me? So first of all, I need to give Nathan. Nathan got it right. Nathan says A and E will be a doublet. Okay, you will get 1 point for that. Tell me, can someone tell me, after you know this is a doublet, can you tell me what range of ppm are you able to detect this hydrogen A or hydrogen E? They're identical. 5. Okay. Okay, only one neighbor for A, you're right, Kathy. Okay, so who said that first? I think Cindy said that first, right? Aromatic hydrogen will be in the range of 7 to 8 ppm. Okay, very good, Cindy. Cindy, you get 1 point, okay? Love it. Your mistake on the 2.3, yes. 2.3 belongs to the benzylic hydrogen. It's not aromatic. Okay, benzylic is 1 carbon away, additional, okay? You need 1 more carbon. All right, my next question. Cindy, can you help me? Can you predict the pattern of hydrogen B? And you know it's gonna be the same as D, okay? Can you predict the splitting pattern of hydrogen C as well? Can you reply back? If not, okay, can someone else, whoever gets the answer first? Cindy says D, oh, wait a minute. So Nathan says DCB will be triplet. Thank you, Nathan, you got another point. Thank you. You got it. Okay, and so triplet, yes, because hydrogen B will be next to this, I mean, 1 neighboring hydrogen here on the A, from the A, and another hydrogen C as a neighbor. So hydrogen B has 2 neighbors, and N equals 2 now. For this reason, hydrogen B will have to be a triplet. You are so right, okay? Thank you, Nathan. And whoever gets the first answer, I can only reward 1 student, okay? And who said B and D will be doublet? No, 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 no. No, Kathy, B and D have 2 neighbors in total, okay? All right, all right. So for both, you get triplets. All right. My next question, hello. My next question. Which size, which peak, is triplet a bigger peak compared to the doublet or smaller peak? Do you have a big triplets compared to the, okay, so I want you to compare the hydrogen interval, okay, and tell me the relative size of A, B, and C. Benjamin says big size for the triplet, including B, C, D. But you know B and C. Benjamin, can you tell me, are they supposed to be showing up at the same time? The B and then C, are they supposed to show up at the same time, at the same ppm? I can tell you, no, you're right. Okay, Amanda, you're right. Okay, because they are not in the same environment. Okay, so they both are triplet, I agree, but they will appear in different locations. If you give me a good NMR machine, they get distinguished, okay? And you know the triplet of B, because I have another same B across the plane. This triplet will be much bigger than twice as big compared to this hydrogen C. The same triplet in pattern, but the size of B is bigger because it has another same kind of hydrogen across the across the aromatic ring. Do you agree? Okay. All right, Benjamin, I'll give you 1 point. Okay, not the same ppm. Very good. Okay, so we have a lot of exercise along the way. Okay, do not worry. You have many opportunities to collect points. So we all understand we have 3 types of hydrogens. We have doublet, triplet, and triplet. Are you following my arrow? Okay, doublet, triplet, and triplet. And hydrogen B is a bigger triplet compared to hydrogen C, a smaller triplet. Hydrogen integral will be 2:1 ratio. This is a much bigger peak compared to the other hydrogen C. Okay, all right, can someone tell me on the next question? We have a di-substituted ring, okay? Okay, we have a di-substituted ring. And R1, R2 are not equal. And these 2 substituents are in the ortho position. Ortho. They're not equal. R1 is not the same as R2. And can you tell me how many different kinds of hydrogens are here? And when you answer the question, you will not get 1 point right away. You have to answer my subsequent questions, okay? All right, Lazo, did you say, wait a minute, who says 4 type? There will be 4 type, you're right. Cindy? All right, Cindy, can you help me now? Can you make prediction for, because they're all different, okay? And depending on whether this R1 is more electron withdrawing compared to R2 or not. You know, A, B, C, D will appear in different sequence, okay, in different positions. And if R2 happen to be the most electron withdrawing substituent, for example, nitro group, how about that? Ooh, nitro group is super electron withdrawing. And if R1 is methyl group, oh, methyl group is not electron withdrawing at all, then you know hydrogen A will appear first. Am I right? Yes, okay, because that hydrogen A will be in the most deshielding environment. Am I right? Okay. On top of that, Cindy, can you tell me, can you make prediction of this splitting pattern here? Cindy, for A and B and C and D, what do you expect to see in terms of splitting pattern? Three new messages, most naked, no doubt. Okay, A will be doublet, you're so right. And B, come on, why is B a doublet? Tell me, why is B a doublet? Sorry. I was typing so fast, okay. You know, for this reason, I know people are in competition. I know, that's why I need to narrow down to only 1 student now. Can you answer the question 1 more time? Hydrogen A is a doublet, how about B? B has how many neighbors? B is triplet because it has 2 neighbors. So how about C? C is also, wait a minute, C is also triplet, yes, because I have 2 neighbors. How about D? D says, I have how many neighbors? I only have 1, so D will be a doublet. All right, Cindy, you get another point. Love it. Okay, great job, okay? And therefore, can someone else, okay, Cindy, you already shine like a, you know, sunny day. Can I offer this opportunity to someone else now? Can you tell me? Can you tell me which peak? Which peak? Oh, wait a minute. Because they're all different, then so they're all different in the ppm. So tell me, what is the ratio of hydrogen integral here? Can someone tell me what is the hydrogen integral here? A, B, C, D. Can you show me? Cindy already got the mini points picked up. So I will offer this opportunities to someone else. What is the hydrogen integral, the ratio between these four in terms of hydrogen integral? A, B, C, D. What is the ratio? It means 1 to 1 to 1 to 1. You're so right. Nathan, you got another point. Nathan already got 3 points. Nathan, you're good at NMR, huh? I'm proud of you, okay? Very good. So for ortho disubstituted ring, you will have 4 sets of peak, okay? Doublet, triplet, and then doublet. You will have 4 distinct peaks, okay? If you give me a good NMR machine, I'm not saying bad NMR machine. Sometimes you don't have a high resolution NMR machine, then there's a limit, okay? All right. And I want to show you that if you have an ortho, then the splitting pattern will be so different compared to the meta disubstituted benzene ring. Okay, we already talked about the ortho, and I want to talk about the meta now. All right, who wants to answer the question? Can you say yes? And I'll put you on this bonus point opportunity. Can you make prediction on the splitting pattern? And tell me how many different types of hydrogens are here and how does it look like? Come on. Now you have a meta. You're just moving the substituent to somewhere else. It is the same practice, same N+1 rule. Kathy, thank you. You're right. You have 4 different kind of hydrogens. Can you, yes, you said hydrogen A is a singlet, B will be a doublet, C is a triplet, and D is also, okay, what did you say about D? You said D is a doublet. Of course D is a doublet. D has only 1 neighbor. Okay, is there any question about this? No. Is A a neighbor? No, you're too far from me, okay? You're not my neighbor, you're 2 doors down. I only care about next door neighbor, okay? Remember, this hydrogen will say, this is my mom, this is my neighbor, okay? Hydrogen, mother and neighbor. There's only 1 neighbor, okay? And this is not neighbor, okay? This is not neighbor to D. No, too far. Okay? All right. Let me give. So who gave me this answer? Well, I'm confused now. Why don't I give Cassie 1 point? I'll give Lazo 1 point. How about that? Okay? I really want to encourage you to interact. Okay, because I need to make sure you understand this very simple molecule. Because let me tell you, you never know. This may be in the final, okay? So I want to show you, hey, in the meta, compared to ortho, remember here you only have doublet, triplet, triplet, doublet. In the meta, my goodness, you see a singlet now. Am I right? Because this is a isolated hydrogen. Okay, so for a di-substituted ring, if you see a singlet, it means it's isolated, is most likely it's a meta di-substituted ring, okay? All right, thank you very much. Gonna keep going. Everybody agree? Yes, let me move forward, okay? And I'll talk about other examples later. Let's talk about the para. Para. All right, tell me, someone can tell me how many types and what is your prediction on the splitting pattern? Aaron, thank you. You're so quick. 2 different kind. Can you tell me 2 different kind and the, okay, and Megan says doublet. Okay, can Megan, can you tell me, Megan, how many doublets are there? How many different doublets are there? Megan, are you here? Right, all of them are doublets, but how many doublets are there? Oh, are there only 2 doublets? Yes, Farrell. But Cindy said that first. Cindy, can I give that bonus point to Farrell? Because she responded so many times. Wait, why? Okay. Because R1 and R2 are not the same, okay? So that's why you have a doublet here. I have no argument. The B also have a doublet, and you know that C and B are equal because it's symmetrical, okay? I give you a symmetrical plan right here. A and D are identical because symmetry. If you flip this molecule 180 degrees, having this R1, R2 face downwards now, then you know the A and D same, B and C are the same, and they're all doublets. There are only 2 kinds of doublets, am I right? But I want to give Megan 1 point, okay? She really tried hard, okay? And then Farrell, I'll give you 1 point, okay? Is that good? All right. So when you say machine para will give me a doublet and a doublet, and are they supposed to be equal in the size? When I say size, meaning the height, are they supposed to be the same height? So if R1, R2, if R2 were R1, if they are identical, then you only have 1 type then, am I right? Because they're all in the same environment. Am I right? Jocelyn, did I answer your question? Yes, very good. Okay, all right, we'll come back to more questions like that later, okay, when you have even more symmetry. Okay, all right, so can someone answer my question? Hello? Are they, I know they are supposed to be doublet, and this is doublet, and these 2 are the same. These 2 are the same. Are they supposed to be the same size in terms of the hydrogen integral? You know hydrogen integral, right? Yes, Cindy, you're right. Kathy, you agree. Thank you. You're right. They're supposed to be the same size, okay? Because you only have 2 of each kind. So because 2 hydrogens for each, they're the same height, okay? They are the same height. Okay, and so let me tell you, when you get more and more like tri-substitute, it becomes really, really simple because you have fewer hydrogens to worry about, okay? I will not come to that. I mean, you can actually exercise yourself, okay? And look at this molecule right here. Look at this molecule right here. This is actually easier than this one because this is supposed to be a singlet, and singlet, all in different positions. So you see like a fork. Ah, yes, a fork, okay? Singlet, singlet, singlet together. How about here? Doublet, triplet, and doublet. A far more complicated splitting pattern than this, okay? So I just wanna tell everyone here, okay? Is this supposed to be important? Yeah, it is important, okay? You bet. This is a common sense to all chemists on Earth. If you have para disubstituted ring, you will have a pair of doublets, okay? And I want to go back to more symmetry now. Look at this. Look at this. Look at this, okay? Look at this example. How many kinds of hydrogens are here? Two. Super. Who says two first? Lazo? Thank you, Lazo. Tell me, what do you expect for a splitting pattern? Lazo, you're right. There are only two. Okay, so these two are the same. These two are the same. But what do you expect for the multiplicity? A will be a doublet and B will be triplet. You're so right. Lazo, get another point, okay? Yeah, so n+1 rule applies without worrying about any consequence, okay? Let me tell you, at your level, this is all you need to know, okay? When you learn more and more chemistry, the chemistry major, I will have to tell them other things, okay? But not you guys. This is all I want from you. You already have, you can handle this knowledge very well. I'm so proud of you. Now look at this. If it is a disubstituted ring like this, okay? Tell me. Okay, now I want to reserve this question. I want to put this question as a 2-point question, okay? Because I will ask you some other questions. So number one, how many different kinds of hydrogens are here? Number two, the splitting pattern. Number three, how many different kinds of carbons? Okay, how many different kinds of hydrogens are here? If you say 4, you're wrong. You said 3. Thank you, Nathan. Let's continue. Now you already got 3 points, okay? You're getting another point. Good, good for you. Because I see this is the one type. The C, of course, is independent. These two are identical. Again, the plane of symmetry. When you flip, they're equal, okay? All right, one more. Nathan, stay here. Nathan, stay here, okay? If I change R to methyl group, CH3, can you tell me how many different kinds of carbons are here? Okay, now listen carefully because this is not supposed to be easy. If I give you a methyl group here, R1 equals methyl group. Boy, 7, let me see. You're right. Okay, singlet for A, B and D, or B doublet. and C will be triplet. Yes, you're right, Nathan. Okay, and I want to ask the question about carbon. So Kathy, did you 3 type of hydrogens? No, you're wrong. 6 carbons. Let me see. Okay. Is this 1 carbon? So 1, 2, 3, 4. Am I right? Already on the ring, it is 1. Okay, I'm between 2, like 2 substituents. I'm different. I'm very special. This carbon will say, hey, I have an alkyl group directly next to me. I am special. Yes, you are special. I agree. So 1 and 2 and 3 right here. Yes, because I'm 1 carbon away from the substituents and I'm 2 carbons away from the carbon A. Can I call this a carbon A? Okay. And the C says, yes, I'm also different. Hello. Carbon C will say, I'm actually meta to this substituents. Of course, I'm special. Okay, so 1, 2, 3, 4 already on the ring. So in addition, there is a methyl group. Am I right? So let me tell you. Okay, the rest will be just symmetrical. So the answer is 1, 2, 3, 4, 5. Who says 5? No one. Okay. So 1, 2, 3, 4, 5 on the methyl. Okay. Is this supposed to be fun? Okay. Are you ready for the next one? Let's do it. Okay. Here. Can I do this one? If I have, oh, wait a minute. Yeah, I can change this. Hey, ignore R1 and R2. Can you change both into methyl group and tell me how many different kind of carbons are here? Hello. 5? Cindy, did you say 5? It will be 5. All right, let me see. Okay, so let me start from here. Okay, I always want to start from the one that is most substituted, okay? Because I don't want to forget it later. Students usually ignore, there is the carbon right here, where I'm pointing at, okay? Where my hands are. Right here, there is a carbon, okay? Say 1, 2, 3. Hey, wait a minute. Is this the same as that? Is this the same as that one? Yes, so 1, 2, 3. Yes, and then the methyl group is number 4. So who gave me 4? No one going to give me 4. All right. Is this supposed to be difficult question? I can tell you this is a little bit tricky now. Am I right? All right. That's why I need to give you the review. Okay, ladies and gentlemen, I have to give you the review for this reason. All right, let's come back. Did I talk about this yet? All right, let's do this one then. Okay. All right, do one more question right here. One more question right here. This time I'm going to change it to a more difficult question, okay? Ready? Okay. If R1 is a methyl group and R2 is an ethyl group, can you give me the number of carbons, different kind of carbons here? Okay, write down on a piece of paper, R1 is now methyl, R2 is ethyl, so it's C2H5. Someone gave me 7. Ooh, Lazo, you really have a great potential. Whoever says 7, I'm proud of you, Lazo. You got another point. It is 7, okay? Because I want to start from the most substituted right here, okay? This is 1 type, 2 type, 3 type, and this is number 4 type, right? Is it? Sorry. It is not 7, sorry. Who says 8? Kathy says 8. Who else says 8? Kathy, Cindy. Do you mind? Can I give Kathy another opportunity? Because, oh, wait a minute. Yeah, Cindy, sorry. Let me give it back to you. You already collected 2 points. I'll give you another chance to collect another points. Okay, you have 8 carbon. You're right. Okay, because 1, 2, 3, 4, 5, 6. They're all different. All right. So wait a minute. 1, 2, 3, 4, 5, 6. They're all different, right? 1, 2, 3, 4, 5, 6. All different, but here you have additional ones. So this is number 7, number 7 there, and then 2 more in here. So the answer is 9 in total. So it's not 8. It's not 8, okay? So whoever were able to come up with 9, I can tell you it's not easy, okay? What? Yes. You don't believe it? Can you draw on a piece of paper? Okay? You'll realize each carbon here, okay, there's no symmetry. They're all different, eh? Hello? So this 6 carbons are all different, okay? And so 6 plus 1, 2, 3, 6 plus 3 is equal to 9. Can you count them? I couldn't follow. So Lazo, are you able to figure out? It is tricky. Yes. Do you think we will not give you a question like this in the final? Yes, we will. We will. Okay. Do you hear me? We will. Okay. All right. Am I done? Not really. I can tell you there is another common mistake. Okay. Am I able to move forward? Hello? Yes? Okay. You know, Nathan, you got a lot of points picked up. I love it, okay? I want to help students, okay? All right, let's do another exercise, okay? And the reason I want to do it is because you guys made a whole bunch of mistakes right here. Oh, by the way, before I walk away, right here. A lot of students just make mistakes on the last questions, the last 2 questions you submitted. This is page 87 on your, and this is the Padia's lab manual. Okay. The common mistakes here. People say this is a para disubstituted ring. And I said, no, this is the meta disubstituted ring. Okay. If you have a para, remember it's gonna be like this. Para, you will have a doublet and you have a doublet. all right, and equal height. Same here. If you have a di substituted in the para position, you will have a doublet and doublet because, yes, you only have two types of hydrogens. You have two types of hydrogens on the ring. And why am I only looking at this? Because this is where the aromatic ring hydrogens are located. Okay, right here. Maybe 6.8 to 8.5, this range, okay? 7 to 8. This is the time you eat dinner, okay? You have your dinner time, 7 to 8 o'clock right here. This is the aromatic ring. You enjoy the aroma of food. Aroma of, hey, how about my baking potato is really good, I can tell you, okay? 7 to 8 o'clock. All right, and why do I have to mention 7 to 8? This is very unique to aromatic ring, okay? If you don't even know this, aha, I guarantee this may be in the final, okay? In the final exam, you probably see it again, okay? All right, and if you have a di substituted ring in the 1,4 position, you only see doublet, 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 doublet. If you have mono substituted ring and you have, oh, they're all different. Okay, 1, 2, 3. You have 3 different kinds of hydrogens and they create a blob together. Okay, and because you have symmetry right here, so the peak jam in the same position and give you a huge blob. And why is this meta? Because I can see the B here definitely is a singlet, am I right? And I do see clearly I have a singlet right here, ladies and gentlemen. I don't see doublet, that's why this is a meta, okay? A meta. Do you get it? Ladies and gentlemen, do you get it? Okay. Are we done for the NMR? No, not quite yet. I need to give you another dosage, another dose on the NMR review. Yeah, this is the second visit. Yes, you're right. Okay. We really want you to, yes, review, and let me give you some more exercise. Are you ready? I need to talk about your common mistake, okay? This is one of it. The other one is this. This is on the first visit. I asked all of you to figure out how many different kind of hydrogens and how many different kind of carbons. Okay? That was the question. So I told you this is a difficult question. I gave you cis 1,2-dimethylcyclopentane and the trans. I give you cis and trans, and so go ahead and draw that molecule. Okay, Miss Jean, did you label the answer for me? Yes, I did. Okay, and so start from my methyl group. I call this hydrogen A, and the one pointing. Okay, you know, in the cyclo structure, we call one of them is axial and the other one is equatorial. It doesn't matter, okay? It is just a different direction to this plan, okay? To this plan, 5-member ring. Okay, so one goes above, one goes downwards, okay? And so this is 2 different kinds of hydrogens. Am I right? Okay. And so this is type C because this is different from either one. Type D, yes, it's different than any of them. Type E, yes, I'm 2 doors down. Yeah, so I'm different. F, I'm on the opposite side, 2 doors down. Of course, I'm different, okay? And then you see right here, do you see how I label this? This is hydrogen B, hydrogen C. This is equivalent to this one because I have a plane of symmetry right here. From this tip right here, I can draw a line and this is where it goes for the symmetry. I can flip, okay, and you find this 2 in the same equivalency, the same identical environment, I should say, okay? Am I making sense? Okay. And so look, this A is the same as this, of course. I have a symmetry right here, so these 2 are the same. And the B will be identical to this right here. Okay. Are you following my arrow? So how many different kind of hydrogens are here? What's your answer? The answer is 6, okay? Because A, B, C, D, E, F, total of 6. So how many different kind of carbons are here? Can you answer? I can tell you most people got it wrong. By the way. Anyone answering this? Can you tell me how many different kind of carbons are here? Okay. I can tell you, I see some people are able to answer my question. It could be 4. Quintero. Quintero. Why do you say could be? It is 4, okay? Just look at this. Carbon A, carbon B right here. Am I right? Hello? Is this carbon B? Yes. Carbon C, carbon D, and then it's symmetrical. Am I right? Thank you. Thank you. Okay. I like it. Okay. I think I want to, no, for this one, I think I already explained everything right here, and I want you to do this, okay? For the trends, can you help me answer the question? How, well, you already saw my answer on the hydrogen labeling. So you're seeing 1, 2, 3, 4, 5 in total. I can see a plane of symmetry right here. Where is the plane of symmetry? It is actually this pentagon. You may say, Ms. Jane, this methyl group is sticking up. It's different than the one sticking down. I can tell you. What do you mean up and down? When you flip this 5-member ring, okay, then this is one sticking up, this is one sticking down. Okay, so I can tell you there are equivalent, okay? All right. I am going for 7 kind of carbon. No way. Come on. For trends? 6? No, please. This is not Las Vegas, so we're not gambling, okay? We're not randomly guessing. How many different kinds of hydrogen here? According to my answer, I just want you to count. I'm not going to give you credit. How many different kind of hydrogens are here? It's already written here. Hello. How many? 5. Cindy, you're right. Benjamin, you're right. I already labeled for you. There are 5 because these two are equivalent. Once you flip the pentagon, they are identical, okay? What do you mean up and down? They are the same, okay? Because the plane of symmetry itself is the pentagon, okay? So they're equal. Miss Jing, I don't understand. One more time, what do you say flipping the pentagon, I get the same? Okay, you may say, all right, now hydrogen here, hydrogen E, why are you special? Okay, now you are the hydrogen, you're saying, because I am on the same side of this methyl group, so I am special. I'm different compared to that hydrogen. I can tell you, this hydrogen will also argue. Just flip this molecule, okay? I can tell you, I'm on the same side as a methyl group as well, okay? And also, I'm 2 doors down, okay? The same as you are, 2 doors down. So why are you special? We are equal, okay? We're equally special, okay? That's why, okay? So the type of hydrogens are 5. I can tell you most people screw up these 2 questions, okay? And I want you to see it one more time. So you tell me how many different kind of carbons are here? It's easier now. Different kind of carbon, hello? Cindy, Lazo, you know something? I have to really nominate you guys, you both ladies are I'll say the queen of NMRs. You always give me good answers. You're right, there are only 4 kind of carbons, okay? I will reward Cindy and Lazo, okay? 1 point each. Amazing. Yes, there are only 4. And actually, I already wrote down for you, for the hydrogens, it's actually easier for the carbon, okay? It's 1 type here, 1 type here, 1 here, and 1 here, because these 2 are identical, okay? 1, 2, 3, 4, the answer is 4. Professor, can you explain again why both are, why both are what? Are E? Young lady, one more time. I call this hydrogen E, okay? Hydrogen E will say, I'm on the same side where the methyl group's sticking up, so I am special, okay? There is argument between these 2 hydrogens, and E says, I'm special because I'm on the same side, sticking up at the same direction as methyl, and this hydrogen will say the same, because when you flip, then this methyl group will go up, and this one will go down. Am I right? Ah, love it. You know, when I learned chemistry the first time, just like you do, I was not able to answer for trends, I can tell you. Okay? So I know this is a difficult question, okay? And I was a hardworking student, hello. Okay, now you get it. Okay, it requires a lot of training to the eyes, okay? It's easy for you to see if you have a modeling kit in your hand, but I think my drawing is good enough, okay? Can I move forward now? Thank you, Brittany. You know, it really, I want students to feel comfortable. Okay, I'm able to spend quality time on the Zoom lecture because I have more time to explain to you. Okay, in fact, we have a dry lab. It's a blessing. You're not busy in the lab, or else I have to look at the clock. Hey, it's already 3 o'clock. I cannot talk anymore, okay? Go back to the station. I want you to deliver the result. I mean, here we have more time, okay? So take your time. If you cannot digest, let me know what's bothering you, okay? All right. I'll give you 1 more minute before I step forward to the next concept, okay? This is again for NMR. Are you ready to go now? Are we ready to go? Can you type? Yes, thank you. Yep, good. Let me move forward, okay? And this will be the last slide for today. This is the HDI exercise, okay? Okay, ready to go? I want you to calculate the HDI of this molecule. What is it? It is asking you how many double bonds you have. Am I right? Come on, there's only 2 carbon. Okay, you can draw that molecule. It's called methane, ethane, propane, butane. So this is the ethane, am I right? Is there a double bond? Is there a double bond? HDI means, yeah. Do you have any hydrogen deficiency index? That's asking you, is there unsaturation here? The answer is hey, how come no one answer? Are you still there? Am I talking to myself? I'm scared. Zero, no double bond. You're right, there's no double bond. Zero all the way, thank you. So I want you to calculate the HDI of this guy. Who says, okay, I want you to calculate, there's no double bond. Zero. What did you do to tell me it's zero? Because I just have to replace 1 hydrogen with bromine, and then it's the same backbone, right? So when you calculate the HDI and you see halogen, are you going to be scared? No. I can just look at this halogen as hydrogen. Am I right? Are you with me? Yes. Okay. Because actually when I create this halide on a piece of paper, I could just use the same ethane and replace one of the hydrogen with bromine, am I right? And so there's no unsaturation, okay, Ms. Jean? I know, okay? All right, go ahead. Calculate the HDI here. Okay, so from here you learn, you can just treat the bromine as if this is another hydrogen when you do the HDI. Here, Nathan, you said it's 4, okay? So whoever, all right. Yes, okay, now I know you can do this quickly. You learn the equation. How about this guy then? Question number 4. What is the HDI for this compound with the bromine? The answer will be Nancy Trent. You said 3. You're right, Nancy. I want to give you 1 point, okay? Okay, I want to help, okay, students who respond, finally, respond with 3 right here, because I can just treat this as a hydrogen. So I can calculate as if this is a C8H12 oxygen, yes. And that is the final answer. The answer is 3. Very good. Very good, very good. So am I done today? I can tell you I'm done. In terms of the review on the NMR, I'm done. Okay, I want all of you to remember I did a long exercise with you. I spent 1 big hour doing the same, NMR concept, but I'm touching up a lot of mistakes, and this is a new trick, okay? When you do the HDI, all halogens can be regarded as hydrogen, okay? All right. All right, so let me tell you, I'm done for today in terms of lecture. I want to take questions from the floor. Are you able to do the post-lab questions in the back? And do you have any question? If not, I'll just let you go, okay? We can call class dismissed, and I'll see you next week. Any question at all? Yesterday, someone asked me, Miss Jean, on the post-lab questions, there is theoretical yield. What are we going to do with that? Well, you just use the quantity coming from the lab manual and you do the calculation assuming it is 100% conversion to the end product. From the amount of the reagent provided, depending on the molecule you're assigned to do, you should have a theoretical yield coming from, remember, the mole calculation and the limiting reagent. Okay, you want to give me theoretical prediction based on the mole calculation, based on theoretical yield, based on all the moles being used, considering the limiting reagent, okay? But the actual yield can be 0, okay? Because we're not running the experiment, so actual yield is 0. You can still do your theoretical yield, understand? Okay? For part 2 of the table, yes, we do not put any data. You want to put all the data except the actual yield. Actual grams, you don't need to report it, okay? And you can say, my yield is 0. We all understand, we didn't run it, okay? Any other question?
So we don't put percent yield or grams?
You need to do theoretical yield, okay? I think I gave a question about theoretical, am I right? But in the table, we want you to report the grams you actually synthesize in the lab, and that grams is 0. We didn't do any, right? So
Yes, you're right.
in the box, yeah, in the box you can enter 0 there, but for this theoretical yield calculation based on moles and predict how many grams should be formed, your target ester, you should be able to figure out the grams of the theoretical. Okay? Do you get it?
Yes, thank you.
Good, thank you. Anyone else has a question? I can tell you the due day is tomorrow, and I think I put 5 o'clock, okay, as a deadline tomorrow, 5 o'clock, okay? And scan a good copy for me, okay? And
So it's not due today?
no, it's not due today.
Oh.
Well, we know life could be really difficult for some students. I can tell you, there was a student writing to me, Miss Jean, I don't really have a good connection at home, internet connection. Okay, so they are not able to view the YouTube or whatever. Okay, so I need to upload the video later. So the student can view the photo again and then video again and write the answers. Understand? So it happened to one of my students. So I understand I need to give more leeway to the deadline. Okay?
I appreciate it. Thank you.
Okay, thank you. Anything else? If not, then I'll say adios then. Hello. Do we want to say goodbye to each other? Hello. Hate to say goodbye, but
Bye.
bye
Have a
bye.
good day.
Have a good day. Next time, okay, I want you to view the study the aldo reaction the same way. Okay, and I'll give you more information to prepare yourself. Okay, all right. Nice weekend, everyone. I'll see you next week. Bye bye.